down, yeah. I've been feeling so down, yeah.
Had no need to fight tonight.
Hi guys, I want to tell you about introduction of application of differentiation. What is application differentiation? Differentiation and integration can help us solve many types of real-world problems. One of the application of differentiation is apply maximum and minimum. The process of finding maximum or minimum value is called optimization. Derivative is applied to determine the maximum and minimum value of particular function. The objectives are to find the value of x and y and to find the minimum cost to make the project. Let's see the example of question together.
Let's figure out MAT183 problem that related to minimum and maximum problem, which can be solved by using differentiation application. So the problem is a rectangular area has to be fenced off to create an enclosed flower garden owned by MAT183 by using 600 meters of fencing. So from this first sentence, we can imagine that there is a rectangular area. So this is the rectangular area. This rectangular area has to be fenced off by using 600 meters of fencing to create an enclosed flower garden. So the information that we get from this sentence is the fencing is 600 meters. Alright. And then MAT183 has 3 kinds of flowers to plant, and she wants them to be kept separated. So there is 3 different flowers. So we have to divide the rectangular area into 3 parts. So 1, 2, and 3. So and then what is the largest area that can be enclosed? So what is the largest area that can be enclosed? To find the area, we have to know the width and the length of the rectangular area. So we take the width and represent it as x, and the length and represent it as y. And then from the information we know that the perimeter of the fence is 600. So from this we can create an equation which is 600 equal to 4x plus 2y. 600 is the total of the total length of the fence. So where did we can get the 4x? As I said just now, x is represent to the width. y. So 1, 2. So therefore 2y. Okay, 2y, and that's the first equation that we can get from this problem. So to find the area, let's continue to the next step.
Let's resolve the equation together.
Okay, let's continue to find the solution. Okay, like Salsabila said before, we need to separate the 3 power, and our width is x and our length is y. Okay, for the width, we have 4 width, which is 1, 2, 3, and 4. So we get 4x, and then we have the length, which is y, 1 and 2, so we get 2y. So our parameter is 600, so 4x plus 2y equals to 600. So now we already get the first equation. So for the second equation, we will need to get the area. So our formula for area is x multiplied by y. For the third equation, we need to take the first equation and then let y equals to x. So 4x plus 2y equals to 600, and move 4x to the right, 2y equals to 600 minus 4x, and then y, and then we move 2 to the right, and then 600 minus 4x divided by 2. Okay, now we get the third equation, which is y equals to 300 minus 2x, because we already simplified it. Okay, now for the first step, we included 3 equations into 2 equations. So we get a equals to x multiplied by 300 minus 2x. So we will multiply it 1 by 1. So we get 300x minus 2x power of 2. For the second step, we need to differentiate it. Okay. Now we have for the a, we have 300x minus 2x power of 2. So when we differentiation it, we get 300 minus 4x. For the third step, we need to let dA per dx equals to 0. So our dA per dx is 300 minus 4x equals to 0. And then we solve it, we get x equals to 75. And then our fourth step, we need to differentiate it again. So for the second differentiation, we get dA per dx equals to 300 minus 4x. So second differentiation, we get negative 4. So it is less than 0. Therefore, 75 will maximize the area. Okay, but now we're not done yet, because the question wants the largest area that can be enclosed. So the next step will be continue with my Sarah.
Just now, Putri has explained how to determine the value of dx. As you guys see from the slide above, x is the width and y is the length. So now we continue how to find the y, which is the length of the rectangular area. First, we can see from the equation given, y is equal to 300 minus 2x. So how to find the y? We can substitute the x value from the equation of y, which is it can be y equal to 300 minus 2 and substitute the x, which is 75. So calculate, so the y will be 150. So now we have the both value, which is the length value and the width value, x and y value. How to find the area? The area, how to find? We can use the area formula, which is x multiple with y. Area formula is actually width multiple with the length. So x multiple with y, 75 equal 75 multiple with 150. So calculate, can get 11,250 meters. So what we can conclude here is the largest area that can be enclosed are 11,250 meters. So the largest area is the rectangular area that can be enclosed, and that is the area.
So the next one is the conclusion part. What we can conclude for this conclusion part from the questions: first, we need to identify or understand the problem state. In this case, we need to find the area for the rectangle part. Okay, we need to calculate and identify, or first thing first, you need to identify the length and the width to make the calculation to be easier. And y is the length and x is the width, so it's more easier if you identify it firstly. So next, substitute the value correctly, okay, and differentiate the a over the x correctly, or else the value will be wrong. As you know, if the one value are wrong, so it causes all the answer will be wrong. Next, substitute the value of x and y to the formula rectangular area correctly, which, as you know, area for the rectangular part is length multiple with the width, and the length is y and the width is x, so y multiple with x equal with the area. So lastly, what we need to make it important is the unit. Okay, the unit for the area is meter squared.
Thank you for watching.